Tonight's movie is on cells and batteries. Cells are estimated to be about a $60 billion industry globally, and that is going to increase over time. Cells provide portable direct current electricity from a chemical reaction. Currently, cells have a maximum potential of about 3.8, and that maximum has been around for about 10-15 years, and we're trying to find ways of getting higher cell potential, but it's unlikely we're going to get much better than that based on the chemistry that we're seeing right now. Batteries, as opposed to cells, are made up of 2 or more cells, so devices producing under 4 volts are really cells in virtually all situations, not batteries. But in the general public, we misuse the word, and we frequently call everything that really is a cell, we normally call it a battery. So we shouldn't use that terminology. We should be using cells when they're small voltage, and when there's several hooked up in series, they're batteries. Moving on now. There are 3 types of cells. The first one is primary cells. Primary cells are single use, which means they cannot be recharged. You probably have a whole bunch of these around because they're pretty cheap to produce, and we make them in standard size like AAA, AA, D, 9 volt are often primary cells. Examples, most of the ones you have are called alkaline dry cells if you've actually looked at the name. So that's the one that is available almost everywhere. Mercury oxide or silver oxide ones are used in hearing aids and those flat ones in watches. And you can also buy lithium primary cells, not the same as the lithium battery we're going to talk about later. Lithium cell we'll talk about later in the secondary. But these are single use, but they're very high quality, and they're more expensive, but they're used for expensive applications where you need power under difficult circumstances, like say cold temperature applications. The problems with these different types of cells range based on the chemistry. Alkaline have a short working life, so you put them in, they work for a little while, and then they give up, which means they produce an awful lot of waste. The term alkaline means basic, so they're also rather corrosive, and you may have noticed that if you've ever had one of these cells leak out. The silver or mercury oxide, silver is expensive and mercury is toxic. And those lithium cells are much more expensive than the alkaline dry cell, and with almost no warning they just stop working, so you have to always have spares just in case, because you never know when they're going to give up. So those are your primary cells. Moving on now. Next we have secondary cells. These can be recharged, so that distinguishes primary from secondary. Secondary can be recharged, primary can't. And many of these are reusable over 1,000 times. They are more expensive to buy at the start, but because they are rechargeable, they are cheaper in the long run than those primary cells. Several examples. One that was quite common about 20 years ago was the NiCad, or nickel cadmium. So a lot of older power tools and some of the less expensive new power tools, cordless, are of this type. Almost all of us are familiar with a battery in a car, and those really are batteries. They're 12 volt batteries, a series of 6 lead acid cells. Nickel metal hydride, which were also used for some power tools and frequently used for digital cameras, and available usually in a AA, AAA size. And the lithium ion secondary cell, which is what's used in a lot of the newer power tools, and your cell phone, I can pretty much guarantee, will have a lithium ion cell, as well as laptops, iPads, tablets, all of those types of things. Problems with these, however, NiCads had a memory effect, meaning that if you charge them for 3 hours normally and then once forgot and charge it for 5, now it expects to be charged 5 hours. Or if you only ran it down halfway, the next time it's only going to go halfway down its capacity. So any mistake that you made, they were unforgiving, and you got less and less use of your battery. The cadmium in the NiCads were also toxic, so they were a pain to get rid of. And you can recycle these almost anywhere that you can buy them. Lead acid batteries for your car are quite heavy, and the lead is toxic, and obviously the acid is acidic and therefore corrosive. Nickel metal hydride and lithium ion are expensive to buy. They are the most expensive. We're finding that the nickel metal hydride, it wasn't as good as the new lithium ion in terms of the energy density compared to the weight. And so the nickel metal hydrides are falling out of favor, and lithium ion, of all of those secondary cells, is proving to be the most useful for those power tools and that type of application. Expect to see the lithium becoming more and more common. This is the type of cell that they are working on for the battery-powered cars, and that's where most of this is coming from. Moving on now. The last type is a fuel or flow type cell. These are quite different from normal cells that we think about because the chemicals are supplied either from the air or from a tank. So if you use your car as an example, and if it's a gasoline-powered car, we think of a tank with gasoline in it, and we burn the gasoline and we use oxygen out of the air. Well, a fuel cell also has a tank, but instead of gasoline, it'll have another material, and it can in fact use oxygen out of the air, which most of them do. They are quite expensive compared to every other system, but they are also quite reliable. There are two examples. The first is hydrogen, which is used in 3 specific applications. They've been testing them for fleets of buses, and the space program relies quite heavily on this, and emergency power backup systems. The companies that use credit cards, so Visa, MasterCard, all those types of companies, the facility where they process all those transactions, if they lose power for seconds, they lose millions of dollars. So they have a system with a hydrogen fuel cell backing up the standard power grid, so that in the event that they lose power, in under a second they are back up and running using hydrogen from tanks. And they've got a whole bunch of tanks connected, so when one tank goes empty, the next one automatically turns on, so they can just keep running and producing electricity so that they don't lose power. Space program, hate to have an open flame inside the space capsule, so a tank supplying electricity is the best way to go. The aluminum, in contrast, the way it worked was you used a block of aluminum and used oxygen out of the air, and your product was primarily aluminum oxide mixed with a few other chemicals. It was a nice idea, but there were a few problems. The problems with the hydrogen is that hydrogen, of course, has to be pressurized, and so you got to pressurize the tank. Hydrogen is a very small molecule, it can leak out, so you need to have a really good quality seal on the tanks, and if there's an accident, it can catch fire or explode. Aluminum blocks have to be replaced every so often, so much like people sometimes go to a oil change facility and get their oil changed by some professional, what you'd have to do with these aluminum blocks is you'd pull in every 2,000 to 3,000 kilometers, and they would remove the partial aluminum block, whatever is left, and they'd have to give you a brand new block of aluminum. So it would be a little more often than an oil change, but less often than topping up with gasoline or diesel. But you have to, at the same time as you replace the block, you've got to drain out whatever this aluminum product is. Aluminum as an ion can be toxic, but the great thing is you get the recycling out of it, because every time you bring in that aluminum slurry that comes back, you drain it out, you send the slurry out for recycling, and it comes back as a block of aluminum for the next time somebody needs one. So there's a lot of opportunity there. That's our lesson on cells. Thanks for watching.